Grade 11s, welcome to Learn Extra Live Maths. It's Indy and Tamlin with you today.
Hi, how you doing?
So good. Happy
Good.
2013.
And to you and to all of you guys out there too.
I know, we're off to a cracking start.
Yeah, it really has been. It's been
the
a good
first show. Well,
Yeah.
actually the second show, but the first day.
first day.
Yeah.
Everyone's raring to go.
Exactly. We have got tons and tons of grade 11s on the page that are so excited for today.
Awesome.
So, do you want to tell them what we're going over?
Today, I'm sure you guys have all started it in class already, is exponents and surds and all the laws that we have to go through with those. So we've got a nice full lesson for you today.
Fantastic. I'm so excited. Do you want to take your spot
Sure.
by the board?
Thanks.
And I'll do my usual. Okay, guys, join us on facebook.com/Learn Extra. You can also chat to me, Indy, on Twitter @Learn Extra. If there's anything you need help with, please post it in the Facebook page or on Twitter, and we will help you. If it's not me, it's going to be one of the mindsetters out there, because at the end of the day, we are a community of mindsetters helping each other out. So now, before we start, Tam, I'm going to take a little bit of your time.
Okay.
Just a tiny bit. We need teachers out there to help us with content. We need help us to develop content. So what they need to do is they need to email content@mindset.co.za. I will post it on the page so you can pass that on to your teachers. Fantastic. And before we start, it's very, very exciting, guys. I want to say a big up to Macmillan for proudly sponsoring the grades 11 and 12 Mindset Learn Extra Math shows. So big up to you guys. You guys are so awesome. So now, I think it's time for a lesson. Hey?
I think it's time.
Yeah.
Let's go.
Let's do it.
Right, grade 11s, welcome, and I really look forward to having an awesome lesson with you guys today. What we're going to be having a look at today, as we mentioned, is exponents and surds, and let's have a look at what we're going to be going over in this lesson. First things first, we're going to be looking at simplifying any expressions with exponents in them, multiplying and dividing with powers. And just to give you a little note there, that guys, that's important as far as your syllabus goes this year. Very, very common questions come up in your exams with regards to those. Adding and subtracting our powers, and again, that is important stuff over there. And finally, solving exponential equations and simplifying surds, which obviously also is as important. So certainly not as, all of that is going to be extremely important for your syllabus with exponents and surds. Right, let's do a quick overview of some revisions or some concepts that we need to be clear on and make sure that we are understanding. Okay. I'm sure by now, grade 11s, we're all very familiar with our number system, but just to give us an overview, make sure that everyone's clear. Our big rectangular block over here is what a diagram representing your number system. Okay, you can see that what we've done is divided it into two separate categories, being our real and our non-real numbers. Okay, let's talk about real numbers. We have certain categories within that real numbers, and let's see what each one of them involves. Real numbers, remember, essentially is all your numbers, all your possible values that are found on our number line, okay? Positive, negative, fractions, decimals. If they fit on your number line, they are real numbers, okay? If, however, we take our real numbers and we eliminate certain values, we get certain different types of numbers in our number system. So starting off with integers. Okay, so right, our integers, remember guys, your integers are all of your positive and our negative numbers, but please remember that those are excluding all your fractions and decimals. So when we're working with integers, no fractions and no decimals, something like negative a half, it's not considered an integer, it's considered then a rational number. If we're working with, once we've got integers, the next type of numbers we can talk about just quickly is our whole numbers. Remember, whole numbers are our counting numbers from 0 up in the positive direction of our number line. We've got our natural numbers all going from 1 to up in our positive number line. And then rational, remember rational and irrational. If we can write our fraction in the value of a over b, where it's an integer over an integer, we're working with a rational value. And our irrational, remember, is in if you have sort of a value such as, let's say, square root of 2 over 2, the root of 2 is not an integer, so therefore, remember, the way we classify it is we say that it's non-terminating or non-recurring, and therefore we say that it is irrational. Okay, very, very quick overview. In terms of non-real numbers, if we have the square root of a negative, for instance, that we're going to refer to as non-real, and that doesn't fall part of our real number system over there. Okay, very quickly, let's go through our laws. Oh dear, this is not going away. Okay, there we go. Right, first law, remember when we're multiplying bases, as long as the bases are the same, our rule, I'm sure we remember, is we add our exponents. So if I had an example such as a to the 4 times a to the 3, remember guys, your base of a stays a, and I would have to the power of 7, all right? Similarly, if I had a base of 2 times by base of, 2 squared times 2 cubed, remember, your base is the number of 2. So in this case, your base would stay 2, and we would add our exponents, and I would have 2 to the 5. Okay, so that's our first law of exponents. It's not going away. Okay, all right, let's just talk about the next one. Sorry, we can't get rid of those shades, so let's just write it over here. If I have a to the n divided by a to the m, all right, remember that rule. When we are dividing bases, we are going to subtract our exponents, all right? If I'm raising a power to a power, so if I've got a to the n, and I'm multiplying it to the power of m, remember that rule there, we are multiplying our exponents. So that is going to be written as a to the n times m, where that was a to the n minus m, okay? All right. We've got anything to the power of 0. Okay, I'm sure we remember by now that anything to the power of 0, grade 11s, is always going to be written as 1. And I have got anything with a negative exponent. So let's say I've got n to the negative 1. If it's got a negative exponent, we make it positive by bringing it down to the denominator, or vice versa. If it was a negative exponent in the denominator, we'd bring it up to the numerator to make it positive. And most of the time, that's what we're expected to do, is to write our sum with positive exponents. Okay. All right, so that pretty much covers our laws. Very quickly, let's talk about prime factorization. Okay, when we're simplifying expressions where we have exponents, prime factorization is something that we must do as sort of a starting procedure so that we are able to actually simplify our expression fully. Okay, so for example, if I had something like 27, we don't want to leave it as 27. We're going to write it as 3 to the power of 3. Writing it in that form brings in the exponent, and then obviously we can apply our laws of exponents. So that's what we want to always remember to do, is to prime factorize. Okay, if we have a quick look at the two examples we've got here. 8 squared, okay, remember 8 is written as 2 to the power of 3. And if we're raising that to the power of 2, remember our law, when we're raising a power to a power, we multiply, and that gives us 2 to the 6. So similarly, if I've got 27 to the x, 27 is going to be written as 3 cubed, and raising your power to a power is going to give us 3 to the 3x. Okay. Right, grade 11s, that's just a very brief overview of your laws and what we need to look out for, a lot of which obviously we've already seen and we already know, but we want to show you just how to apply them on a grade 11 level. Okay. All right, guys, let's quickly go through one or two examples. This really is also just sort of going back to grade 10 for a minute, making sure that we understand how do we apply these laws without getting too technical with them just yet. Right, let's look at the first one. We've got 2x cubed y, and that's all being cubed, times by 5, x to the 5, y to the 4, and that's all being squared. All right. A small caution, guys, please watch out that if you've got a number such as 2 inside your bracket and it's being cubed, you do not times that 2 by 3. That 2 is being raised to the power of 3. So this 2 over here is being raised to the power of 3. My x, remember, if we're raising a power to a power, is going to become x to the 6. And I'm going to have y to the 3. Times by, I'm going to have 5 squared. We'll have x to the 10 and y to the 8. Okay, so multiplying those two expressions together, I will have 8 x to the 6, y to the 3. I'll have 25 x to the 10, y to the 8. And, okay, our calculators, I haven't got my calculator here, it's 200. 25 times 4 is, so 200 x to the 16, and y to the 11. Okay, so what we did is we multiplied our whole numbers together, but then whatever my bases were, as long as the bases were the same, we added our exponents. Okay, so that one over there, a good grade 10 example. Let's move on to something else. All right, bearing in mind that often you're going to be asked to give a solution which has positive exponents. Okay, so in an example such as this, once you've simplified it, make sure your exponents are positive. And the way we do it is as follows. I've got 9x to the negative 2 over 27, x to the negative 3. Just to point out one or two things to you here, grade 11s. Do you notice that just the x is being raised to the power of negative 2, and just this x is being raised to the power of negative 3? So you're not bringing, when we bring our x's to the numerator and to the denominator in order to make them positive, the 9 and the 27 do not go with it, okay? If, however, it looked like this, if it was 9x and the whole bracket was to the power of negative 2, that's a different story, because now that whole term is being raised to the power of a negative. So if you were to make that positive, just as an example, the whole thing would come down to the bottom to be positive. However, if I'm sitting with just 9x to the negative 2, the 9 is actually staying where it is, because that's not being raised to the power of a negative. It's only the x which is. Okay. All right, let's have a look over here. So if I've got 9 over 27, if they are standing alone and without being subjected to the exponent, we could simplify that to 1 over 3. Okay. Let's take this x to the negative 3 and let's make that positive by bringing that up to the top. And if I've got x to the negative 2, let's make that positive by bringing that down to the denominator. So that's going to simplify. I've got 1 over 3. Now, here's our law that when we are dividing bases, the same bases, we subtract our exponents. So if I've got 3 minus 2, that's going to leave us with x to the 1. Okay. And so obviously we're left with just a third x in that example over there. All right. Okay, grade 11s, those were two relatively easy examples. I hope everyone's following me with those two. And let's have a look at what else we've got here. Okay. In our grade 11 year, a question such as this, guys, becomes quite a common question in terms of exams and assessments, and something which is really important that you all understand clearly. Okay. What they've given us over here is 81 to the power of a plus 1 multiplied by 9 to the power of 3 minus a, and that's all over 27, a plus 2 times by 3 to the 1 minus a. Okay. Right, do you recall in our overview in the key concepts in the beginning, we mentioned prime factorizing, okay? And that is a really important thing that we have to do over here in order to simplify our expression down fully, okay? So, 81, we need to get that as a prime factor. So if we were to break it down, 81 can be written as 3 to the power of 4, all right? Now, I'm going to, for now, keep that inside a bracket because we're still raising that to the power of a plus 1. We are multiplying this by 9. Now, 9 is the same as 3 squared, and we are raising that to the 3 minus a. This is going to be over 27. Now, 27, if we break it down into its prime bases, is going to be 3 cubed, and that's to the a plus 2. And 3, well, 3 is already a prime base itself, so we leave that one alone, and that's what we are sitting with. All right, so we all quite clearly see what our first step is in this kind of sum, is that we break everything down into as small a prime base as possible. Next step, we tidy up a little bit. So I take my base 3 and I multiply. Now, here's a mistake I often see people make, and it's really a silly mistake. This 4, please make note, it gets multiplied to both the a and the plus 1. It's like a distribution, okay? We're multiplying them. So therefore, please make sure that it's 3 to the 4a plus 4, all right? And same applies over here. The 2 is getting multiplied to the 3 and the negative a. So I've got 3 to the 6 minus 2a. That's going to be over. I've got 3, and once again, we multiply it to both those exponents, so therefore 3a plus 6. And finally, I've got 3 to the 1 minus a. All right. Okay, so this is quite a nice situation now because all the bases are in fact 3. And our rule is, remember, when we're multiplying bases, we can add our exponents. And if we are dividing our bases, we are going to subtract our exponents. Okay, so let's put that together. So I'm going to take the base of 3 and I'm going to add the two exponents that are being, where the bases are being multiplied together. So I've got 4a plus 4, and I'm going to add on to that 6 minus 2a. All right? Now, the denominator also has bases of 3. So let's do this in one go. When we're dividing bases, we subtract our exponents. So therefore, if I've got a 3a plus 6, if I bring that up, it's going to become minus 3a minus 6. And if I've got 1 minus a, when we bring it up, it's going to be minus 1 and plus a. Because remember, when you subtract a negative, it will become positive. Okay. Right, that's quite a long line of exponents there, but let's simplify it now. Right, I've got 4a minus 2a, which is going to be 2a. I've got minus 3a, so 2a minus 3 is minus 1, and 1 cancels out. So all my a's, in fact, cancel each other out. Then what are we left with here? I've got a 6 and a 4, which is 10. 10 minus 6, which is 4, and 4 minus 1, which is going to be 3. So in fact, that all simplifies right the way down to 3 cubed, which is 27. Okay, so there we go. That's an important sum. So let's just quickly talk about it again for 1 second here. Take note, guys, that first of all, everything here in this sum is being multiplied together, okay? There are no terms that are being separated by any pluses or minuses. Everything is one term. So that's the first thing I want you to notice. The second thing, remember, is that you are going to break everything down into their prime bases, okay? And once everything's broken down, now remember your prime bases are always going to be 2 and 3, 5, 7, but that's starting to get quite large, but it's still a prime base. Those are the numbers that you want the bases to be, okay? And once we've prime factorized all our bases, we then tidy up by raising the powers to a power. We group it all together by taking anything where the bases are being multiplied, we add our exponents, and anywhere our bases are being divided, we subtract our exponents. And it simplifies generally to quite a nice, tidy answer. Okay, guys, I'm sure you've probably seen these in class already, and they are extremely important to understand. Right, what we're going to do is let's have a short break, and when we come back, we're going to give another one of those a try.
Okay, guys, it's time for an ad break. Tamlin's having such fun. I think she could go on without a break, to be honest. I think if it wasn't for me wanting to get water, she'd just carry on until the grade 12 show. Guys, thank you so much for tuning in. Caroline says, so nice to be joining you, loving the show. Let's have a look here. Nsovo says, thank God, I can't wait for 6 o'clock grade 12. I'm too hot. It is so hot in the studio. On that note, I'm going to go get some water. You go do the same, and we'll see you now after the break. Hi guys, and welcome back. I hope you enjoyed that break and you're really having lots of fun, grade 11s. If you are struggling with anything, please post them on our page and we will try to go through them at the end of the show. Also, let us know if you're enjoying the show. Let us know what you've been thinking. Like, how were your holidays? I've just missed you all so much. Join us on facebook.com/learnextra. You can also chat to me, Indy, on Twitter @learnextra. There's so many new faces. There's so many old faces as well. Let's have a look. We've got Daniel, we've got Lebogang, we've got Michael, we've got Polite, Saretse, Cookie. Loving all the conversation going on the page. Okay, Tamlin, I think let's not waste any more time. Keep those questions coming, but I think it's time to carry on teaching.
Fantastic. Right, let's carry on, guys. Let's have a look at a similar example just because we really want to make sure that you guys are understanding how these sums work. Right, once again, if we have a look at it, I've got a base of 4 to the x plus 2, my base of 8, my base of 2, and my base of 16. And the first thing that I want you guys to see is that the bases are all being multiplied together. Okay, so because they're all being multiplied together, we're allowed to go through the process of prime factorizing and then adding and subtracting our exponents. Okay. All right, so let's have a look and see. If I've got 4, we're going to start the same process again, and we're going to write that as 2 squared, which is to the power of x plus 2. If I've got 8, we're going to write that as 2 cubed, and that's to the power of x minus 1. I've got 2, which is to the x minus 3. And I've got 16, which if we prime factorize it is 2 to the power of 4, and we're raising that to the x. Okay. So step 1 done. Once we have prime factorized, now we raise our powers to a power. So we're going to multiply. So I've got a base of 2, which is then going to be 2x plus 4. Multiplied by my base of 2, and if I multiply by each of the x and the negative 1, we're going to land up with 3x minus 3. I've got 2 to the x minus 3. And finally, I have got 2 to the 4x. Okay. Once again, in this example, as we had in the previous one, all of our bases have actually landed up now being 2, all right? It can happen that your bases land up being different, such as some of them are bases of 2 and some of them are bases of 3. If that happens, grade 11s, what you then have to do, obviously, is group together all the bases, with everything that's got the same basis. So we multiply everything with a base of 2 together and add those exponents, and we'd group together everything with a base of 3, for instance, and we would add those exponents. But in this case, we're lucky enough, we don't have that. We just have a base of 2, so it should be fairly straightforward. We're going to take our base of 2, and remember, when we're multiplying our bases, we're adding our exponents. So I've got a 2x plus 4. I'm going to add 3x minus 3 to it. Then remember, when we subtract our bases, when we divide our bases, we subtract exponents. So it would be minus x plus 3, and finally minus 4x. Okay. Right, so my base of 2, and we have got a 2x and a 3x, which is 5x. A negative 1 and a negative 4 is also negative 5x. So once again, those cancel. All right, and what we are left with is our minus 3 and plus 3, which in fact will cancel out. So we're left with 2 to the power of 4, which is going to become 16. Okay. All right, so those are 2 examples for you on when we multiply and we divide our bases and what we do with those exponents. Okay, so now that we know how to do those, let's have a look and see what would happen if we gave you an example that looked like this. Okay. The key difference here is that in this case, the terms are not all being multiplied together. I'm sure you can quite clearly see that I've got a minus separating the terms in the numerator, and I've got a plus separating my terms in the denominator, okay? So the main law, the main thing that we may not do, all right, I'm sure you've heard your teacher say it 100 times, is that you may not cancel over a plus or a minus sign, okay? So a major, major no-no would be canceling those, for instance. We are not allowed to do that, okay? So please watch out. Again, it happens that people sometimes think that that's what we can do, but please no. All right, so make a note next to your sheet here. If you're writing this down, please make a note that you cannot cancel over a plus or a minus. So what do we do? All right, what we need to remember is that if there is terms being separated by pluses or minuses, factorize them, okay? And in this case, the way we're going to factorize them is we're going to look for a highest common factor. That's what our goal is over here. Okay, right, let's start with this though, guys. I've got an x plus 1, so I've got a double exponent over there. So just to make my highest common factor a little bit more clear, what I'm going to do is I'm going to split that and write it as x to the 5 times by x to the 1. And I'm going to do the same over here, x to the 5 times by 5 to the negative 1. All right, so I've just separated the bases with their exponents. And let's do the same down below here. So I've got a 5 to the x and a 5 to the 1 plus 5 to the x. All right, hopefully we can all very clearly see that in the numerator, I've got a common factor of 5 to the x, and in the denominator, I also have a highest common factor of 5 to the x, okay? So let's take that out. If I've got 5 to the x, which comes out of my numerator, what we are left with is 5 to the 1 minus 5 to the negative 1. And down below here, again, if I take out my 5 to the x, what we are left with is 5 to the 1 plus, and if the whole term of 5 to the x comes out, remember what you're left with inside your bracket is a value of 1. Okay, so the whole term of 5 to the x has come out, and we were left with that 1 over there. Okay, so now, because we've now created a multiplication sign between the 5x and the bracket, now we are allowed to cancel them. Okay, so this is where those will cancel each other out, which really gets rid of the problem of the x and the exponent, hey? So what are we left with? I'm left with a 5 minus, now just remember that 5 to the negative 1 is going to be the same as 1/5. Okay, and I'm left with 5 plus 1, which is going to be 6. So let's see over here. We're going to have to just do a little bit of a fraction here, where we add our fractions, which is going to become 25 minus 1, all over an LCD of 5. And instead of dividing by 6, we all remember the method of tipping and timesing. I'm going to multiply it by 1 over 6. Okay, 25 minus 1 leaves us with 24 over 5, times by 1 over 6, where my 6 will cancel with my 24 4 times, and we are left with 4 over 5. Okay, so the key difference is that in the previous examples, we had all of our terms multiplied together, whereas in this example, because of that plus and that minus, we were not allowed to cancel over anything, so therefore we had to take out the highest common factor, and by doing that, we were allowed to cancel. Okay, right. Just to make sure we get the message home, I want to do one more of those examples. Okay. Right, guys, similar story. You can all see the same format here. We've got our expression with exponents in it, and we are separating, the numerator has got terms separated by a plus. Okay, so when you see that, I really do want you to try and remember that that's what we're looking for. Okay, try and take out a highest common factor and see if that works, if that helps us to cancel it. Our double base of 3 to the x plus 2, let's start by separating that. So I've got 2 multiplied by 3 to the x times by 3 to the 2. I've got a plus, and then I've got 3 to the x times by 3 to the negative 3. Okay, so we can see what I've done there. I've just simply split the bases and given them each their own exponent. And 3 to the x times by 3 to the negative 2. Okay, so once again, having done that, now the next thing to do is to identify that common factor. And it's generally the one where we have an exponent with an x in it. That's the one that we want to take out as our common factor. So, doing that, if I've got 3 to the x, let's put our equal signs here, that's going to leave us with 2 times by 3 squared plus 3 to the negative 3, and we're sitting at everything over 5 times by 3 to the x times by 3 to the negative 2. Okay? And those will cancel each other out. Okay, so we can all see how that works. 2 times by 3 squared, which is 9, so 2 times 9 is 18. This is going to be 1 over 27. Okay, and down below here, I've got 5 times by, and basically that's 1 over 9. Okay. Right, finally we'd have to find an LCD, and we would have to find an LCD of 27 and an LCD of 9. Okay. At this stage, I don't have my calculator up on the screen, so I'm not going to, I'll leave you guys to finish that one off for me. Just remember, if you find the LCD of 27, what you do to the bottom, you do to the top, so you're going to take 18 times 27. And then, once you've simplified the denominator, just remember that you have to tip and times it to simplify. Okay, so you should all manage to finish that one off on your own. Okay. Right, so we've had a look at just basic expressions with exponents and simplifying it. We've had a look at the laws and how we use those. Then we've had a look at expressions where we are either multiplying our bases with exponents or where we're adding and subtracting. And the adding and the subtracting, remember, we've got to try and factorize it first before you can do any simplifying. All right, so that brings us to the next part of our exponents, which we did deal with a little bit last year, which is our exponential equations, okay? Just like any equation, an exponential equation, we're finding the value of the variable. So we'll be solving for x or whatever the variable happens to be. Okay. So what I want to do first is let's just take a look at a basic one of the ones that you really would do right in the beginning of grade 10, just to refresh our memories as to how we go about doing this. If I have got 2 to the power of x, which is equal to 16, remember the idea, guys, is that you want to get the base on either side of your equal sign to be the same. All right? If we can do that, once the bases are the same, we can drop the bases and we make the exponents equal to each other. So if I have got 2 to the x is equal to, instead of writing it as 16, let's again prime factorize the base, which is going to be 2 to the power of 4. 2 to the power of 4. Okay, right, so having done that, we can all remember now when those two bases are the same, that would mean therefore that my value for x is equal to just 4. Okay, so we all remember how that works. Okay, let's then see if we can apply it to one that's a little bit more tricky. And what we've got over here, this time, is 5 times by 2 to the x minus 3, and this is now equal to 80. Okay, just watch out for order of operations here. Bear in mind that that x minus 3 is only being applied to the base of 2. Okay, so would I be trying to sort of get 80 down to a base of 2? Not yet, because what we actually need to do first is get rid of our 5. Okay, so we're going to divide 80 by 5. And if I've got 2 to the x minus 3, which is equal to, 80 divided by 5 leaves us with 16. Okay, so it actually gets us back to a very similar place to what we were in the previous example, because if I've got 16, that's going to then be written as, again, in its prime bases, 2 to the power of 4. And if we simplify that, we can then drop our bases, and our exponent of x minus 3 is equal to the exponent of 4. And we can then just solve it normally, where 3 will come over to join 4, and we land up with 7. Okay. Right, grade 11s, I hope you guys remember that from last year. And what I would really suggest is, although you guys have probably gone on to ones a lot more complicated than that, go back to your grade 10 work and revise those, because this is important to remember, and it can also start getting a little bit involved and tricky, and it's always good to go and practice. So what I think we're going to do is take a short break, and when we come back, we're then going to have a look at ones that involve a little bit more complicated working out.
Okay, guys, let's take a little break. I think we've got some thunder and lightning going. I can hear the booming in the background, so I think it's nearly time. Well, I think it is time to take a break. Anele, welcome, joining in. There are so many grade 10s that are now in grade 11 and grade 11s that are now in grade 12s. We are so proud of all of you, and we cannot wait to get this year off to an amazing start. We'll see you now after the break. Hi guys, and welcome back. Cabello says he cannot wait for the grade 12 show, so you grade 12s, you better not leave. You guys are up next. Gladwin says, I wish there were no short breaks. Feel like going maths. Hey, I know, if only we just had an hour of pure maths, I think the teacher would be a bit frazzled, but at least we'd have lots of time. Dr. Tulani, thank you so much. He's always on the page, but now he is not in grade 10, he is now in grade 11, so welcome to grade 11, and we can't wait to see what you do in grade 12 mindset, but we can't wait to spend 2013 with you. So now, without further ado, I'm going to send you straight off to Tamlin. Let's learn more, let's learn extra.
Right, grade 11s, now let's look at an example of an exponential equation that's just a little bit more on the difficult side. What we have over here is now not just one term on the left-hand side and on the right-hand side, but in fact 2 terms, all right? We've got our 2 to the 2x plus 1 minus 2x, which is equal to 8. Taking our minds back for a minute to the example we did earlier, where the terms were separated with pluses and minuses, let's think about what we did, and that was that we factorized. And that's exactly the route I want you guys to take here as well. If I've got 2 to the 2x, what again we can do is, if it helps you, well, it just helps to make it clear, is to separate the bases and write them each with their own exponents, and 2 to the x, which is equal to 8. Okay, so once again, there is a highest common factor of 2 to the x, okay? And taking that out is going to leave you with 2 minus 1, which is equal to 8. Okay, so everyone can see what I've done over there. Terms separated by plus or minus. Look and see if we can factorize that term, okay? Now, 2 minus 1 is obviously left us with just 1, and that's equal to 8. Now, the idea would be that we need to divide 8 by the value multiplied to the 2 to the x, but 8 divided by 1 is not going to make much difference. It's going to stay 8. So we've got 2 to the x, which is equal to 8. Okay? And if I prime factorize, I'm going to say 2 to the 3. So therefore, my value for x is going to be equal to 3. Okay. Right. Easy enough. I know you guys are going to recognize that in your tests now. Now let's see who's really thinking. Okay. So this is what we've got. I've got base 7 to the power of 2x. I've got minus 8 times 7 to the x plus 7 is equal to 0. Okay, so what have I just said? If we've got terms that are separated with plus or minus, we said look for our highest common factor, or at least try and factorize it, okay? Now, the previous example, there were only 2 terms, and they both had a highest common factor of 2 to the x, so that was fine. We've got a little bit more of a challenge over here because we don't have a common factor. If we look at our 3 terms, unfortunately, there's nothing that's actually common in those 3 terms over there. However, if we've got 3 terms, I'm sure by now we're all starting to think, hang on, but could we not maybe factorize this as a trinomial, okay? And if you're thinking that, the answer to that is absolutely, but we're going to use a method that's going to help us out a little bit over here. And this method is going to be called the K method, okay? And this is what we're going to do with the K method. I've got 7 to the x and I've got 7 to the 2x, all right? If I take 7 to the x, which is the one with the smaller exponent, all right, and I let 7 to the x equal k, all right? If I do that, then I'm going to go back to the original sum and I'm going to substitute everything that had a 7 to the x with a k, all right? Now, if I've got 7 to the 2x, if 7 to the x is equal to k, then do you guys agree with me that 7 to the 2x would equal k squared? Okay, so let's put that in there. Instead of 7 to the 2x, we've got k squared minus 8k plus 7, which is equal to 0. Now, that looks much easier because we all know how to factorize a trinomial now. And that's easy enough. So let's break this into 2 brackets. And I've got my k and k. Factors of 7, I can only actually use 7 and 1. And both of them in this case are going to have to be negative. So that gives me an answer for k of 7. Or it's giving me an answer of 1, all right? But if you're using k substitution, please be careful not to think that you're now finished. Because don't forget, k is not what we're solving for. We're solving for x, okay? And remember, what we let k equal was 7 to the x. So the final step of our sum is to put back 7 to the x where you had k. Oh, equals 1, okay. Now, in this case, my bases are the same, and if that's to the power of 1, x is going to be equal to 1. Or, now in this case over here, if I've got 7 to the x equals 1, remember that anything to the power of 0 is equal to 1. All right? So if I'm trying to get my bases to be the same here, this would be the same as saying 7 to the x, which is equal to 7 to the 0. And that obviously then gives us an x value of 0. Okay, so there we go, guys. That's something to watch out for, and it's a very handy method to just keep up your sleeve. The K method helps us to just simplify things down so that we can factorize it, and once we've dealt with the factorizing, we can bring back the exponents. Okay, all right, I hope you guys all understood that one. It's a good and important one to do. All right, just because of time, and I would like to get on to surds before the end of our lesson, is I'm not going to work through the entire example over here, but I'm just going to start you off again, all right? It's a similar example. I hope you can all have a look and see that if I've got x to the 2/3 plus 7x to the 3rd plus 12, There's no highest common factor that can come out of there. So my option is to then see if I could actually factorize it as a trinomial. And this again is where we would say, let the x to the power of a third. Let x to the power of a third equal k, all right? Because if I do that, if x to the third is equal to k, then x to the 2/3 is going to be k squared. And what we're left with is a very similar example to the previous one where I have a trinomial which we factorize, but just don't forget that once you've solved for k, that you must put x to the third back and finish off the example by solving for x, okay? Right, grade 11s, I'm sure you guys have done loads of those in class already, and if you haven't, I'm sure you'll be doing them soon. Okay. Surds is another part of this section which is very important and one that we must actually go through. So let's have a quick look over here and just do a little bit of work with some surds. If I have got, now often the instruction would be take something like the square root of 18, which we all know is not a perfect square, so it's irrational, but they're wanting us to simplify this irrational number over here. And generally your instruction will be without the use of a calculator. So unfortunately you're not allowed to touch those calculators. We have to try and do it without that aid, okay? If you've got the square root of 18, guys, the way you want to approach this if you're trying to simplify it is that you want to take the factors of 18, but be careful which ones you choose. If I took factors of 18 like 6 times 3, neither 6 nor 3 is a perfect square. So that's not going to actually help my situation completely here. Rather, let's look at factors of 18 such as 9 times 2, okay? So instead of writing it as 18, I'm going to write it as 9 times by 2, all right? Now, that's worthwhile to me because 9 is actually a perfect square, which I could square root. So we could write the 3 outside the square root sign because that's the square root of 9. However, 2 does not have a rational square root, so therefore we're going to leave that in surd form. And that would be your value of the square root of 18, simplified without the use of a calculator. All right, so you're looking for factors of that number, ideally one of which is a perfect square, and that's how we go about doing it without the use of a calculator. So if I had this sum over here where I've got the root of 12 plus 4 root 75, and again my instruction is to simplify this without the use of a calculator. I'm going to go about the same process here. First things first, let's look at the factors of 12 of which one would be a perfect square. So again, 6 times 2 is not going to be worthwhile here, but if we say 4 times 3, that's going to help us out. My 4 for now stays outside the surd. 75, if we take 25 times by 3, 25 times by 3 is 75. So that works because 25 is a perfect square. So let's square root 4, which is going to give me 2, but the square root of 3 is going to have to stay in surd form. Now over here, I've got a 4 sitting outside my bracket. The square root of 25 is 5. So what happens is that comes out the surd, and the 4 and the 5 are going to get multiplied together. Okay, and the 3 again stays in surd form. So we've got 2 root 3 plus 20 root 3. And this then leads us to a sum where I've got like terms. Okay, if I've got 2 root 3 plus 20 root 3, it's a similar situation to saying 2x plus 20x. They're like terms, so we can add them together. And that we can then finish off by saying is 22, and we keep our root 3 like so. Okay, and that would then be simplifying it using like terms. If I had root 2 plus root 3, unfortunately that's the same as saying x plus y. They are unlike terms, and you wouldn't be able to add them together. And I think that answers somebody's question earlier on the Facebook page regarding like and unlike surds, and you treat them very much as you do with x's and y's in algebra. So I hope that that answers your question.
So it's not the same as liking and unliking a Facebook page?
Not quite. Okay, so what do we do over here? Let's have a look. Root 48. Okay, we get quicker and quicker at this as we go because we know our timetables well. Hey? The square root of 48, if I take the factors of 48, let's say 16 times by 3. The square root of 32, well, 16 times by 2 is 32. And I've got 12, which is 4 times 3. And I've got 8, which is 4 times 2. All right. So therefore, if I simplify that, the square root of 16 is 4, and we'll be left with root 3. I've got 4 again with the root of 2. Down below here, I've got 2 root 3. And I've got 2 root 2. Okay, so I've simplified each of my surds. Now let's have a look here. We've got a bit of a problem because on the numerator, I've got a term with a root 3 and a term with a root 2. And we've just said that those are unlike terms. You cannot add or subtract those. Okay, so right now there's nothing I can actually do with that in the numerator. And the denominator, same thing. I've got a root 3 and a root 2. I've got a problem. I can't do anything with that. So again, guys, what can we fall back on here? We've got terms that are being separated by a minus, in this case, both on the top and the bottom. So therefore, try and factorize it, okay? And the first thing we always look for with factorizing is your common factor. And if we look carefully, I've got a 4 and a 4 in both my terms on the numerator. So 4 is going to come out to leave me with root 3 minus root 2. And down below here, my 2 comes out to leave me with root 3 minus root 2. Now that's extremely handy because obviously now the bracket on both the numerator and the denominator is the same, which allows us to cancel that out. And what we're left with is a 4 over 2, which is going to give us just 2. Okay, right, so that factorizing comes in a lot here, guys. You've really got to keep it in mind when terms are separated with pluses and minuses. Most of the time, that's what we're looking at doing, okay. Right, do we have any more? Okay, we've got a bit of time to have a look at a challenge question. So let's quickly see what we can do over here. Let's see, I've got 2 challenge questions. Let's look at this one over here quickly. Right, okay. Let's see how we go. Grade 11s, I've got 9 to the power of x plus 1 minus 6 to the 3 to the 2x, and I've got it over the square root of 3 all to the 4x plus 1. And what we're trying to do is to show that it all simplifies down to the square root of 3. So 9 is going to be written as 3 squared. And if we multiply that by both of the exponents, it's going to become 3 to the 2x plus 2. Minus 6 times by, oh, goodness me. That went all over the place. 6 to the 3 to the 2x. That's not going to simplify any further. The square root of 3. Now, the square root of 3, according to your laws of surds, can be written as 3 to the half. Okay? And I've got 4x plus 1. Okay. Here's my minus sign. What am I going to do? Take out a highest common factor. So I've got 2x, and that leaves me with 3 squared minus 6 on the top. And down below here, if I multiply my half to both of these exponents over here, we're going to be left with 4x times by a half, which is going to simplify to just 2x. And I'm going to have 3 to the half. Okay. So, guys, do we see that our 3 to the 2x is going to cancel out? And what are we left with here? I've got 9 minus 6 over 3 to the half. 9 minus 6 is leaving me with 3 over 3 to the half. And remember, if that exponent over there is 1, when we're dividing bases, we subtract our exponents, which is leaving us with 3 to the half. And 3 to the half can be written back in surd form as the root of 3. Okay, so that was a quick challenge over there to just show you how we can manipulate and work with our surds and our exponents all together in one sum like that. But that was improving, and we landed up getting that both sides were the root of 3. Guys, I hope you've learned lots today, and I certainly hope that you're going to go home and, well, stay at home and sit and practice lots and just do a lot of working for yourself. It's an important section, and it's one that really does require a lot of practice and just getting it right. So good luck with that. I hope you guys manage it.
Exactly. On that note, Lucinda actually says, does maths get any more easier than this? And Yolanda says, probably yes, and it just needs practice. And that's exactly what it is, grade 11s. Practice makes perfect, especially with maths. Grade 12s, you are next. Do not leave. Grade 11s, thank you so much for an amazing show. Macmillan, thank you so much for sponsoring this and making this all possible. You guys rock. And I hope that you had an amazing first show. See you same time, same place next week. Grade 12s, see you next. Bye.